Hi, Amy. How are you doing?
Hi, sir. I'm good, thank you. How are you?
Good, very good. So, today you want to learn about circles, right?
Right. New topic.
Yeah. Yeah, new topic. So, I looked into your curriculum, saw all the things which you want to learn. I thought it's
hmm
better to start with the basics of coordinate geometry. And from there, it'll be easier to pick up the whole unit on circles. So, there are a couple of things which are very important for us to understand. Basically, how in coordinate geometry we define a coordinate plane, write equations of lines, perpendicular bisectors, uh, and then tangents, and then circles, right? So
hmm
really, as a we should say prerequisite to your curriculum on circles, we'll focus on coordinate geometry basics. Okay.
Okay.
So let me share with you uh, the material which I have prepared, and then we'll go from there.
Right.
Okay, there we go. Coordinate geometry. I've written triangles as the topic. As since we'll focus more on triangles rather than circle. Okay.
Okay.
To make it interesting for you, I made a circle right there with a triangle and bright bisectors. So we are going there. Perfect. So we're going to today look into coordinate plane basics, distance between 2 points, what is the midpoint, and how do we find coordinates of midpoints, slopes and gradients, equation of median. Now, in a triangle, median is when you connect a vertex with the midpoint of the opposite side. So the line connecting the vertex and the midpoint of the opposite side is the median. Then we'll see how to find equation of a tangent to a circle. So that is to say, if we have a circle right there, and if I have a tangent line here, how do we find equation of this line when we are given equation of the circle, right?
Okay.
That's very interesting. And that is actually getting into your equation part. Your first few questions will be based on what we're talking about. Then we'll talk about distance from a point to a line. And distance from a point to a line that is there, but normally we'll be interested in the shortest distance from a point to the line. So that is again a very interesting part. And then right bisector. Foundation for right bisector is kind of compulsory to understand what real questions could be with circles, since uh, if I have a chord here, for example, right? If I have a chord here, then the right bisector of the chord, for example, let this be the right bisector. Fortunately, the chord was so perfectly placed. Right bisectors will actually go through the center of the circle. So the right bisector of a chord goes through the center of the circle itself. You understand? That is
Right.
another thing which you might have learned in circle theorem or elsewhere, but that is a property of circles. So if I have a chord, for example, this chord joining these 2 points, let's assume this to be a right bisector, right? I mean, I should draw here right angle. So these right bisectors of the chord will go through the center, and so we can find the center of a circle by understanding the equation of right bisector of a chord. You get the idea?
Wait, what's a right bisector? I haven't heard the term
Okay.
before.
So we'll go through that right bisector also. Right bisector, right means at right angles, which is 90 degrees, correct? Bisector means same distance, midpoint. So we'll find the midpoint of the chord. So we'll find a point
Oh.
which is same distance. So use that point, and negative reciprocal slope of the chord will be the slope of the bisector. So that will become the right bisector of the chord. So you sketch, I mean, you find equation of two right bisectors of the chord. Wherever they intersect, that will be the point center of the circle. You
Oh,
understand?
okay, yeah.
And see, here is a very important concept and a question which is a bonus question sometimes. You will understand we're not talking about, let's say, these 3 points, correct?
hmm
So I joined these points with chords, found the right bisector and the circle. That clearly indicates that a unique circle can be drawn given any 3 points. Do you see that? If you have 3 points, then you define a circle uniquely. Just as to define a line, you need to have 2 points, correct?
Right.
So to define a circle, you need to have 3 points. So when you have 3 points, connect them and find the right bisectors. The intersection of right bisectors will give you the center, and the radius is the distance between them, correct?
Wait, so to define a circle, you only need 3 points?
Yes, which are on its circumference.
Oh,
Yeah. So
didn't
that's
know that.
interesting. See, so we are actually today going to learn a lot of concepts which will sail you through the circles chapter. You understand? So
Yes.
most of the time I've seen people, students going back and forth with each and every question as it comes up next in your book, right? So
Yeah.
we'll cover all those questions first, and then we'll get into your real chapter, okay?
Okay.
I'd also like to take up a case where we'll talk about three-dimensional coordinate geometry. Many times circle questions will be extended to spheres and different shapes. So it's a good idea to have, talk about three-dimensional coordinate geometry. And then we'll take up examination style practice questions where I'll pick up one with all the above concepts, right? So when we talk about all the above concepts, we are in circle, okay? A
Okay.
full circle. Do you understand?
Mm-hmm.
That is
Yeah.
how I've defined my first lesson with you. I hope you really find it interesting. We'll begin with, as I said, very simple concepts, and that's the coordinate plane. So what is a coordinate plane? As you can see on the right side here, right, we have a coordinate plane. So normally you draw the x-axis, you draw the y-axis. As soon as you draw this on a piece of paper, the paper has been divided into 4 quadrants, right? We have x-axis, which is also called abscissa, y-axis is also called ordinates. And when you divide, they intersect these 2 axes at a point which is called origin. The coordinates of origin is 0, 0. If you move right, every step moving right on the x-axis is positive. Every step moving up along the y-axis is positive. Moving down or left from origin O, or the axis, is negative, right? So that is what I've written here. So 0, 0 is the ordered pair for the origin. X is horizontal step from origin. Y is the vertical step from origin. Steps to the right or above the origin are positive. Steps to the left or below the origin are negative. You always write coordinate pairs as x and y with parentheses, correct?
Mm-hmm.
Now, a point 0b will lie on y-axis, x value 0, and the point a0 will lie on the x-axis. That is your x-intercepts for a graph. Is that clear to you?
Yeah.
Any point will lie either in the quadrants or it could lie on the axis. Simple as that. And then as far as the quadrants go, this is always our quadrant 1, that is quadrant number 2, this is quadrant 3, and that is quadrant 4. Clear?
Mm-hmm.
That is how we are going to refer to these quadrants. Let's move on and come up with the very first formula. You can take a note, distance between 2 points. The distance between 2 points is given with this formula, which is d equals to x2 minus x1 whole square plus y2 minus y1 whole square. It's not a big deal. It's a simple Pythagorean theorem. So for example, if I have a point here and there, then we are saying these coordinates are x1, y1, correct? And the other coordinates are x2, y2. In that case, what is the distance between these two? Well, let me just draw a vertical line and a horizontal line, and they're going to meet at a right angle, correct? So you've seen that this is like a squared plus b squared is c squared. So this distance from here to here is difference of x values, x2 minus x1, correct? And the distance here to here is y2 minus 1. And so that distance, which we are calling as d, is that. Pythagorean.
Yeah.
The simple Pythagorean theorem gives you the distance formula. So here is a very good question for you. Classify the triangle ABC. So we have a triangle ABC where A is minus 2, 3, B is 0, 3 minus, and 4 is, C is 4, 1. you need to classify the triangle. So when we say classify a triangle, it really means that is it an isosceles triangle, scalene triangle, equilateral triangle, right triangle, or what? Correct. Now,
Mhm.
after that, find the perimeter of this triangle to three significant figures, and then find the area of the triangle ABC. Now, question number 2 is not very difficult, part B that is. You can find the perimeter by finding each distance, length of the lengths, add them up. Not a problem. Now, can you suggest how will you find area of this triangle?
Um, well, since we've got, we can find the area of the, is it a square?
Yeah.
Well, I need to find the sides. So after I find the sides, and if they are the same, then it's a square. And then whatever the area of the square is, I'll subtract it from the three individual triangles that are like
Perfect. So basically, you
not.
find the area of the square and take away this area of these triangles, which is half base into height. Now, those are right angle triangles. That is an excellent strategy. So this strategy can not only help you to find area of the triangle, it could have been any polygon. Do you realize that? It could have been any polygon. So if I give you any polygon, then just make a rectangle over it or square, whatever
Oh,
the case may be. You understand the strategy? So this question is exposing you to some brilliant strategies to find area of any polygon. So you just make
oh.
a rectangle, take away all the areas which are outside for the triangles, and you know the inside polygon area. Perfect. Well, excellent answer. So here is the solution, right? So we will just read these points from the graph itself. Since the graph is given, we can read A, B, and C. Once you have these points, use the distance formula x2 minus x1 whole square plus y2 minus y1 whole square root. Find the length of each side. So we found the length of AB as 2 square root 10, BC as 4 square root 2, CA as 2 square root 10. Right? So you can see from the sides, two sides are equal. So it's an isosceles triangle.
Mhm.
Right? So we have an isosceles triangle, which is answer to part A. B is sum of these two. So just add these radicals. Sometimes the question could be, write the exact value, right? In this case, we specifically wrote three significant figures. However,
Mhm.
sometimes the question will be write the exact value. So you have to write in the radical form.
So yeah.
Yes. And then, as you were saying, area of the inside triangle, you have to take away area of three outside triangles from the inside rectangle. We found that outside rectangle was actually a square of 6 distance,
Yeah.
as you can see here, right? So we get this extreme of -2 and the other extreme of 4. So 4 minus -2 is 6. And then 3 and -3. 3 minus -3 is also 6.
Oh
So we
yeah.
have these two lengths of 6 by 6. And from that, we took away the area of each triangle. Perfect. And
Mhm.
got our answer, which was 16 units square in this particular case. Perfect. So
Just a
brilliant.
random question.
Yes, yes.
If I counted the little squares inside of that triangle, would I get 16?
Okay, but because there are small triangles, not perfect squares, so
Oh.
approximately you will get around 16, yes. So that is also a strategy sometimes to estimate your answer, but it's never going to give you correct answer.
Accurate.
Yeah, it
Also,
won't depend on that. That was being
just
done in grade 1 and 2. Forget about it.
that's why I
Not in
was
grade
asking.
12.
Where did time go?
Yeah, grade
Also,
12 is different. It is not 1 plus 2, right?
okay. What about this method? Since we found the side lengths,
Yes,
can't you do the height of it?
yes.
So the perpendicular height times the base, and then divide by 2. Would you also get 16?
Yeah, of the triangle you mean, right?
Of
So
the actual triangle.
finding this height is not easy. So we are going to look into this in one of our examples, how to find the height of the triangle, right? Because for that, it has to be perpendicular to BC, right? So it is a lot of work. That is
Can't
definitely
you just do? So we found one of the sides is 2 root 10. And
Yeah.
then if you just find the BC by doing the same, like the distance formula, and
Yeah.
then just divide it by 2, and then that's time, so the 2 root 10 squared minus that little length divided by 2, then you get the height.
No, no, no.
Doesn't it work like that?
Okay. You are kind of lucky because you have isosceles triangle. So the point which you're making is relevant. Since this is an isosceles triangle, we
Yeah.
can say that the other side will be half of it, right? And you can use Pythagorean theorem to find the altitude, a square minus b square square root, correct?
Mm-hmm. Yeah, but if it was obviously like a scaling or something, it wouldn't work because it won't be
Yes,
half. Yeah.
yes, yes, yes.
But
And
if I
even
do it like that, would I get
correct.
16?
Yes, yes, you will get 16. So
Oh, okay.
your observation is very good. Since we have AB as equals to CA, so it's an isosceles triangle. Since it is an isosceles triangle, I can find the midpoint. Let's call it M. So I have a midpoint, and definitely this half of this. So this is my other length. So now I can use half of this to find the altitude, right? So let's say height, h. So let me write down height h as equals to a square minus b square, right? So which is 4 square root, I mean, this will be, sorry, this will be 2
2 root 2.
10 whole square, let me write height square here, minus half of this, which is 2 square root 2,
Root
correct?
2, yeah.
Square. So you get the height square, and you can use this height square in your formula. Correct, you could do that. Then,
Oh, okay.
just to remind you, there's another formula actually, Heron's formula. So if you're given 3 points, because triangle has been defined using 3 points, correct? So we know the coordinates of point A, B, and C, correct?
Yeah.
Now assume it's a scalene triangle. So in that case, you use Heron's formula to find the area of the triangle. Is that clear to you?
Mm-hmm.
So somewhere you can write it down that you could use Heron's formula to find the area of triangle also, right?
Oh, okay.
That is also quite complicated. But the method which I am telling you works with any polynomial, right? So remember.
Oh, okay, yeah.
This?
That's the one we want then, yeah.
Yeah, polygon. Correct? With triangle, it is not so difficult. Half of the questions, the triangle will be right triangles, will be even, you know the height, correct?
Yeah.
So if it is a right triangle, if it is an equilateral triangle or an isosceles triangle, it is not a big issue, right? But if it is a scalene triangle, then this strategy is kind of ideal, right?
Right, yeah.
Perfect. So my idea is to give you a few strategies before we begin with a chapter on circles, because there will involve circles and triangles. And so it becomes kind of critical for us to understand, okay? Here is the next question, which is kind of same, just a practice question for you, which says, again, based on this distance formula, find the length of the line segment. So just apply the formula and get. Determine if the triangle with these vertices is isosceles. Exactly same question. Explain the procedure to check if the above triangle is a right triangle. So if I give you 3 coordinate points, how can you find whether the triangle defined is a right triangle or not?
Well, you just said with the Pythagoras' theorem, you can just, do
Perfect.
it.
So there are actually 2 options, and we'll discuss both the options. Let me share with you the solution. So first part is very simple. Find the length of the segment. Substitute the values in the given formula. Once you do that, you get distance as 10, right? Now we're talking about the 3 vertices of a triangle. Again, apply the same formula 3 times. So coordinate geometry means a lot of work, right? Especially finding these square roots. That is distance formula is commonly used. But anyway, keep doing it, and then you get these lengths. And of course, we have got 2 of them as same. So that really means that it is an isosceles triangle. And what we also discover is a square plus b square is c squared, right? That means it is also a right triangle. Perfect.
Yeah.
10 plus 10 is 20. So it is also a right triangle. So that is one way of checking right triangle. Here is another very simple approach, and that is to find the slope. So you can actually find the slope of the two sides. If they're negative reciprocal, then it is a right triangle, correct? So finding slope is faster. You don't have to find the distance. Well,
That's
in
true.
this question, yeah, in this question, we had to find the distance, and therefore that was better, correct? But
Oh,
now,
right. Yeah.
if you're given an option, go with slope for right triangle. Is that okay?
Yeah.
Find all the three slopes, and if two of them are negative reciprocal, you know it is a right triangle. Perfect.
Mm-hmm.
Next example here, we are now coming to midpoint. So when we began with, you remember it was a circle, 3 points, and we had a chord, and we have to do right bisector. First step is to find the midpoint, right? How do we find the midpoint? So here is a very simple formula for midpoint. It is the average value, right? X1 plus X2 divided by 2, Y1 plus Y2 divided by 2. You get the midpoint of a line segment. So that's the formula which is going to be applied. So midpoint of a segment AB is this. Simple example here. So we are given a triangle. I've again taken very simple questions, right angle triangle. Nothing can be simpler than this, right? Even values, you just divide them, you don't get any fractions.
Yeah.
Sometimes you do, but this is the simplest you can get, right? So the idea
Right.
is to understand the concept. So this is one side, find the average value of the x, add them, divide by 2. Then with y, add them, divide by 2. Do the same with all the three sides, get the values which are written here. Simple as that. Now it
Mm-hmm.
says, prove that the area of the triangle ABC is 4 times the area of triangle PQR. PQR is this triangle here. So I made it more interesting, taking a triangle in between. So we are saying this in between triangle is 1/4 of the whole area. Well, from the symmetry, you can definitely see that. But you can
Mm-hmm.
find the area and also figure it out, correct?
Mm-hmm.
You can
So
find
would you just find the area of the whole thing and then find the area of the small one
all
and
things.
just be like it multiplied by 4?
Correct, multiply by 4.
Okay.
So we are also looking into one more aspect here, and that is, uh, from here we get a couple of questions actually. So if I have a triangle, let's say we have a different triangle, not that kind of a triangle, and if I join the midpoints, in that case, the question will be for you, prove that these two are parallel lines. So knowing that this is the midpoint of AB, let's say, and this is the midpoint of AC, for example, this is A, this is B, and this is C. So one question will be, prove that these lines are parallel. So that means
Mm.
you use this formula, find the midpoint, and then the slope between these and BC has to be same. Is that clear to you?
Right. Yeah.
Second question is that this area here is 1/4. This area is 1/4 of the whole area. That makes sense because, when the lines are parallel, we're talking about two similar triangles, right? Similar triangles with half the length. So half base into height, two lengths are half, so it is 1/4, right?
Mm-hmm.
It makes sense. So these are two related questions where the coordinate points will not be as I have shown here. They could be anything, right? How?
Right.
It tells you the concept. Correct. Now, in midpoint questions, the most difficult question is not to find the midpoint, but if you are given the midpoint, then find the endpoint. That is kind of difficult.
No.
So the question is,
Great.
find the endpoint B of the segment AB where the coordinates of A are given to you and the midpoint is given to you. Correct? So let's try to understand this. We have this AB, right? But we are given the midpoint M. We are not given B. In that case, how are you going to find the endpoint? So that is really a difficult question at times, right? We are given these two, and you have to figure out what this is. So in this particular case, again use the same midpoint formula, which is right there, correct? But you know
Mm-hmm.
the midpoint, so substitute the midpoint and substitute whatever you know, correct? The A
Mm-hmm.
values. And then equate similar terms. So first term 1 plus x over 2 should be equal to 4, and then simplify and get the value of x. So you get the x coordinate for b, and then same thing do for the y coordinate, equate it to 6, and then you get the y value as 16 in this particular case. So you can find the endpoint now using the one of the other endpoints and the midpoints. So the midpoint formula can be rearranged and you can actually work out. Perfect.
But with the 1 plus x over 2, don't you multiply the bottom?
So you just cross multiply. Which question?
Oh no, the 4.
1 plus x over 2. Oh, there's a mistake, that means. Sorry. Good, you pointed this out. When you do this, this is 8. And so it'd be 8 minus 1, and this should be 7. So this would be 7 and 16. You're right.
Okay, yeah.
Correct. You have to cross multiply, simplify, and get the value of x. Correct. So 8 minus 1 is 7. So you get 7, 16 as your answer. That is right. Thank you.
That's all right. So, okay, that's quite crucial then.
Yeah, you're paying
attention. Yes, I am alert. Yeah, so knowing that formula is very important. Okay.
Correct. Now let's talk about median. Now, median is a line. So let's see the definition of median. So can you please read the definition of median from here, Amy?
Yes. Median is a line from the vertex of a triangle to the midpoint of the opposite side.
So this line from C to D is the median, right? So, and that is the midpoint. That is what we're trying to say. That is the median from the vertex to the midpoint. Now, it's kind of important that if it is isosceles triangle, in that case, this will also be a right angle, because then these two triangles will be congruent, then the angle will be half of 180 degrees, but not otherwise, okay? Not if it is scalene triangle. Perfect? So remember that part. So median in general is not perpendicular. It's not the altitude, right? Okay. So median is the line, but it will not form part of altitude in general. Okay. So the question for you here is, find the equation of median CD in the given triangle. So you can read the values from the graph itself and find the equation of the median. So to find the equation of the median, you have to, we have assumed that you know how to find equation of the lines and all those things to begin with, but we'll go through that in our solution later. Okay, so it's good. We have taken the solution of that question right here. So solution is, first read the coordinate points. So we read all the coordinate points A, B, and C, which are 1, 2, 7, 5, and 5, 0. Now the midpoints of AB is point D, which is average of X and Y values, came to be 4 and 3.5. Now once you know the midpoint, now we need to just find the slope between C and D, right? We know these 2 points. So slope will be y2 minus y1 divided by x2 minus x1. And when you do that, you get slope of negative 3.5. So you can use the formula y equals to mx plus b, substitute the slope, and one of the points, that better point, is C itself. Substitute 5 and 0 for x and y to find the value of b. So 5 and 0 gives you b as 17.5. So the equation of the median is y equals to minus 3.5x plus 17.5. Is that clear?
Yeah.
So we use the equation of line y equals to mx plus b. We also use the slope formula y2 minus y1 divided by x2 minus x1 to find the equation of the line with a point. And already we are working with the median. Center point is required, so the average value. Clear?
This question will be hard if you don't know what a median is.
Of course, yeah. So definition of median is important.
Yeah.
Now, we are coming to your circle. Slope m is given to you as, you know, y2 minus y1 over x2 minus x1. Equation of the line is y equals to mx plus b. And we also know that for a perpendicular line, the condition is that the product of the slopes is -1, right? So negative reciprocal is the slope of a perpendicular line. Perfect. So that is kind of a review before the question, which is find the equation of tangent to the circle with center 4, 5 at a point 8, 3. So you need to find the equation of the circle, tangent to the circle at A. How will you find this? Tell me. We are given point O and A, and we want to find equation of the tangent line. Yes.
Oh yeah, so I think I would start by finding the gradient of the radius,
Yes.
and then with that, you need to find the equation of the tangent.
Yes.
But you would have to. It would be the negative
Negative
reciprocal, so it would just be yes. So in this case, you've got the slope of the radius as -1/2. So
Yes, yes.
the tangent will be 2 because -1/2 times 2 is -1.
Correct. And then you use that normal, which is negative reciprocal, 2 value, and use the coordinates of point A to find B. And so you get the equation of the tangent. Now, this is also a very interesting question and normally asked in test papers, okay?
Yeah, I've seen so many of like these questions in GCSE.
Yeah.
Like so many. It's crazy.
Correct. Now, next question here is, we're just touching upon the circle now with some properties so that, it reminds you how a circle could be related with triangles and many other things, right? Tangents you just saw. Now, equation of perpendicular line, example 10. Point P, which is A12, is given to us. A is not known, is on a circle with radius 13 centimeters. So we know this length is 13 centimeters. Find the coordinates of point P. Show that RP, this line is RP, this is the point R, is perpendicular to QP in the triangle PQR in semicircle. So a lot of things given to us in this figure, which is the point R and Q form the diameter of the circle. All right. So what we are saying here is point P is on the circle with radius 13 centimeters at the center of the origin. So here at the center O, we have center of the circle. The points given to are P and Q minus 13, 0 and 13, 0, right? So they are on the two sides. So clear, since these 2 points are going through the center, they form the diameter, right? We are not writing that in the question. Do you understand? We are just saying that the center is at origin, and these 2 points are at minus 13 and plus 13. We are also saying that the radius is 13, right? Makes sense. So that is the diameter, and point P is on the upper half of the circle. Clearly, it is in the semicircle. Any triangle in a semicircle will be a right triangle, correct?
Circle theorems.
Yes, circle theorems. But the question is, you have to prove that that is the right triangle, and you have to also find the coordinates of point P, right? So we can use the distance formula. O to P is a straight. So O to P, use the distance formula. Once you use the distance formula, we know the distance is 13, right? So square root of A square plus B square, 12 square in this case is 13, square both sides, find the value of A, you get A as 5. So the coordinates of point P is 5, 12, right? Once you get the coordinates as 5, 12, then it's a question of finding these 2 slopes, and those 2 slopes will be negative reciprocal if they are perpendicular. And that is how we can show that those 2 sides of a triangle are perpendicular. Clear?
Wait, sorry. With P, does it say A, 12?
Yeah. A,
oh, sorry, it's really small. I couldn't see that. Oh, okay, I was wondering where the 12 came from.
Small. Yeah. Yeah, it says A, 12. Yes.
Okay.
Cool. Yeah. It says A, 12. A, 12. That is the coordinate of point P. Correct. So you know Y coordinate, you don't know the X coordinate. So we use the Y coordinate here, and then said radius is 13 square. Radius is 13, right? And then we found it. Correct? That also gives you the equation of the circle, right? This particular equation. Here we are writing x squared plus
y squared equals r squared.
When the center is at the origin, correct? So that gives you the equation of the circle also, right? Now, let's look into examples with right bisector. That's kind of very important to understand as we move along with our unit on circles. So the question here is, find the equation of right bisector of the segment OA, where O is the origin and A is 2P, 2Q. So I've taken a very simple example. Coordinate points also 2P and 2Q, because half of them will be P and Q, right? So the midpoint can easily be found. So first, right bisector. Right bisector of a segment. Line perpendicular to the segment through its midpoint. That is the right bisector. So this, if you have a line, we have to first find the midpoint of the line, right? So let's say this is the midpoint. That means these two sides are equal. And after that, we have to do the right bisector, means a line which will be perpendicular to this. That is the right bisector. Clear?
Can I just take a quick
Sure.
picture? It's because it's easier when it's like visually done instead of like words, you know. Yeah.
Good. So steps to find the equation of the right bisectors are given here. First step is find the midpoint of the segment. In our case, we have 0 on one side and 2P, 2Q on the other side. So the midpoint is PQ, right? Now then the second step is to find the slope. So we found the midpoint. Now we need to find the slope itself, correct? So slope is simple because this point is 0. So y over x, correct? So q over p is the slope. Rise over run, correct?
So the point on the far left is 0.
Yeah.
O, and the part on the far right is A.
Correct.
Oh, okay. Sorry, I thought the point where you like crossed was O for some reason. Sorry. Yeah.
So
Okay.
do you see that? Correct. So I took a very, very simple example. So since this was 2P and 2Q.
Oh, yeah. Makes sense.
Coordinates are PQ here. So clearly this height is Q and this is P. Is that clear to you?
Yeah.
Okay. So we get this triangle and we know the slope M. Q over
Correct,
P.
yeah.
Perfect. So we now know the slope also. Then we have to find the slope of the perpendicular and negative reciprocal. I'm writing normal N here minus P over Q. Flip it and change the sign. The slope of the perpendicular. Now the equation of the bisector, we know the midpoint, which is PQ. We know the slope, which is minus P over Q. Use your point slope form. Y minus y1 equals to m times x minus x1. Are you familiar with this equation?
No.
Point slope form of a line, okay? To make a note of this, I prefer to use this line equation. You know y equals to mx plus b.
Mx plus c, yeah.
B or c, whatever, right? Now, think like this. Let me show you the derivation here. What is slope? M. M is y minus, I can say y minus y1 over x minus x1, correct? Difference between y values and difference between x values give you the slope, correct?
Yeah.
How about cross multiplication? So as soon as you do cross multiplication, you get m times x minus x1, and you're left with y minus y1. Do you see that? Basic.
Oh, yeah. I was always I was thinking how you got to that. Oh, so that's how you derive it. That's quite smart.
Just from the slope definition, you rearrange and you get y minus y1 equals to m times x minus x1. This is really a good equation if the question says, write the equation in standard form. Straight away you get the standard form, okay? And it works well if the slopes or gradients are in fractions. You can cross multiply. In our case, see here now. Let's move on. So we get y minus q, that is the y1 value, and the gradient is minus p over q times x minus p. So now with this fraction, I just cross multiplied. So I took q on this side, and I got a linear equation kind of, right? Without any fractions. Open the bracket, solve, simplify. You get a beautiful equation, which is actually a very important equation px plus qy equals to p square plus q square.
Oh.
Yes.
Okay. Yeah. That's quite smart.
So the equation of the right bisector of a segment, when one of the point is the origin, why did we take origin as one of the points? 75% of the questions in circles deal with center at the origin. Do you understand?
Right, yeah.
It's the origin, correct? The other point, for easy calculation, 2p, 2q, but whatever it could be. But we have an answer here in terms of p and q. You get the idea. So p is half of this coordinate x, half of x, and that is half of y value. This is half of x.
Yeah.
You get the idea, right? So it is actually a very important equation, which really gives you insight to working on perpendicular bisectors in a very simplified way. Perfect?
Right, yeah.
But this could be a test question also. It may look simple, but it is like concept based, right? The concept-based questions are always asked in test papers. So that is what we're looking into. Next question here is question number 12. Oh, we've done 11 questions already. Find the shortest distance from a point to a line. Okay, so we're given a line in this particular case, which is right there, and the point which is here. Shortest distance, how will you find? Can you tell me the steps, please?
The shortest distance.
Yes. You know the distance formula, right? You know a point, but you don't know this point. How will you find this point?
Wait. So, do you have to find the equation of the line or something?
Yes.
Yeah. Okay.
Yes. Easy, right? So first you find, we are given equation of the line 2x plus minus 4. So we know the slope of this line m is 2, right? So slope of the perpendicular will be negative half, correct?
Minus half, yeah.
We know the slope, we know the point, so we know the equation of this line. Is it okay?
Oh, do you have to make the lines equal to each other?
No. Yeah. Lines equal to find the point of intersection.
Point of intersection.
Perfect.
Yeah.
Once you find the point of intersection, then use distance formula to find the distance. Clear?
Yeah.
It involves a lot of steps, right? A lot of calculations. So you have to be in calculation, but otherwise, these are the steps involved. So I hope you understood the method. You know, it's a very interesting review to get ready for circles, right? So the shortest distance of a point will be along the line perpendicular to the line. Is that okay? We are given the line y equals to 2x minus 3 and an external point, which is p, 6 minus 1. Steps involved are find the slope of the line. In this case, m equals to 2. Slope of the normal, which is minus half. Perpendicular line will be going through the point P, which is 6 minus 1, with the slope of minus half. Again, I'm using that point slope form. You like this equation? Very simple.
Yeah.
I minus y minus m equals to m times x minus x1. Substitute.
Yeah.
See, whenever the slope is in fractions, this is actually a very good equation to work with. How easy? Just cross it side. Do you see that?
Yeah.
And then just
so much easier.
You don't have to find b and do all those calculations, come back to the equation. No, straight. You get your answer. In standard form, you could write. So we get x plus 2y equals to 4. Since I need to find the point of intersection, what I could do is either of the two methods, substitution or elimination. Since we know y is 2x plus 3 is this line, and our new line is x plus 2y equals to 4. I am substituting this value inside for this y, correct? So I'm replacing that y with this. And then when you solve this, you get the value of x. So x is 2 for us. Substitute 2 in your equation of line. Y is 1. Point of intersection is 2, 1. Now you can find the distance using the distance formula. Substitute x1, x2, y1, y2, get your distance, which comes out to be 5 units in this particular case.
Wait, what exactly are we finding?
Shortest distance.
From the graph. Yeah, so is it just from the point to that line?
Yes.
Oh, okay. Why did they say shortest distance then?
Well, you could find
the
the
shortest
distance also. This will be longer distance, correct?
Oh,
Correct?
oh, yeah.
Shortest distance.
Oh,
This
okay,
one,
yeah, makes sense.
correct? Yeah, that is why. And then use units at the end if not mentioned. It's good practice. It's good practice. Okay?
Mm,
Is that
yeah.
clear to you? Shortest distance is a very important question from any point of view when we talk about coordinate geometry. And circles, most of the
Mm.
time, they'll give you some external point and say, find the length of the tangent, find the shortest distance from this point to the center of the circle, find the distance between two circles. There are so many other questions, correct? You must have seen many in GCSE, but now in coordinate geometry, we'll use coordinates.
Oh,
Now, we'll kind of close to our end of this particular session. Here is one 3D question, which is not very difficult, but just to show you that we can actually extend all the concepts which you learned to 3 dimensionals, right? So instead of x1, y1, we could have x1, y1, z1, x, y, z plane, correct? So coordinate geometry. But the formulas work exactly same. So the distance formula now will become like this: x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So that third dimension is now added. However, the working is exactly as we did before. Is that clear to you? It makes
yeah.
sense. Since when you want to find, let us say, this diagonal length from A to G, in that case, what will you do? First, you will find the base diagonal, right? So you use this part to find the base. And then to find that, you'll add to the y component. So likewise, you can add each component, correct?
Mm-hmm.
So the formula
Makes
remains kind of
sense.
same. Makes sense?
Yeah.
So anyway, easy calculations, plug the values, get your answer. So I thought we'll end with the circle itself so that now you see how many concepts we have learned just to get to this topic of circle. Question now is, find the radius of the circle passing through 3 points. You need to find radius of the circle passing through the 3 points which are given to you. Can you please tell me how will you find radius of the circle now with all the formulas which you have learned?
Okay. So, okay, wait. Could you start by finding? Okay, so the origin is obviously that point in the middle,
Yes.
and we need to find the radius.
Yes. We need to find that center also.
Oh, that's not the origin. Oh,
Yeah,
damn.
that's not the origin.
Okay.
Not the origin.
I was assuming that was the origin. Can we use the coordinates by just reading off the graph or no?
Okay, we have these coordinates given to you. A is -1, 5, B is 5, 7, and C is 7, 1. So as I was saying right in the very beginning, if you connect 2 points which are on the circle, they are called chord, correct?
Oh, so we
Right
found
bisector of the chords intersect at what point? Tell me.
the midpoint.
Center of the circle. So we'll take the right bisector of the chords. These right bisectors will intersect at the center. So we have learned how to find right bisector of a segment. So we are going to use those principles to find the equation of this line, which is the right bisector of AB, and also the other line, which is the right bisector of BC. Once you have these two right bisectors, they will only intersect at the center of the circle. So we get, let's say, center O of the circle.
Oh, so you make them equal to each other.
Yeah. And once you get the center point, then use any of these points to find the distance, which is radius. Done?
Okay, yeah.
Okay, so we went.
There's a lot of formulas in my head. That's why I was trying to like pick one.
So actually speaking, this question was, let me go through this question once again. I should have mentioned find the center of the circle first. Let me, strictly speaking, this question should be find the center of circle, then right?
Oh, yeah. That makes
Then
sense.
point,
Yeah.
right? Now, in this particular example, the way the values are taken, the 2 points are right across. They form a diameter, so you could find the midpoint of the diameter also.
Oh, yeah. There's so many ways to approach it.
Yeah, no, but that
But
is not general case, okay? But it seems
yeah.
when I look at the diagram, then I say, well, definitely you have the midpoint, so you could use this as the diameter, right?
If you do a quick rough sketch in the exam,
Yeah,
do you think it's better to just find the center because you can't always know if that's the diameter?
you are right. So if you make this rough sketch with these numbers, then you know actually you are given the diagonal. So the halfway is the circle center, and you know the radius is half of diameter. So
Right.
actually you know the answer even before you do all the steps, because there is great possibility of doing a mistake in between.
Yeah. Yeah.
Making a sketch is always a good practice. Okay. However, believe me, in your test, these 3 points will be like kind of like this. Do you understand? They will be like not like that. Is that clear?
Oh.
Okay.
Okay. Yeah.
So I try to go with even values so that I get simpler calculations. Perfect. So I've selected points in that way. However, generally the points will not be like this. Okay.
Yeah.
So Amy, can you please read out the solution?
Yes.
Solution 40. Yes.
So solution 14. Right bisectors of the chord will intersect at the center of the circle. Okay. So steps. Find the right bisectors of the chords AB and BC. Then find the point of intersection of the right bisectors, which would be the center of the circle, which is O. Then the radius will be the length of OA.
Yes.
Or OB, or any of them. Yeah.
Correct. So the steps are find the midpoint first of any chord. So let's say we decide on AB, AB is the midpoint. We use the midpoint formula. Now, once you have that midpoint, then we know we're looking for the slope of this particular chord. Negative reciprocal will give us the bisector, right? So slope is 1 over 3. Bisector slope should be -3. We use -3 and the midpoint to find the equation of the line. This time I've used y equals to mx plus b, well-known equation for getting the equation of my first right bisector. Adopt the same steps for the second chord, which is BC. Slope was -3, perpendicular was 1 over 3, and the equation of the line was y equals to 1 over 3x plus 2.
Yeah.
Once you have both these lines, equate them, and once you equate them, you get the point of intersection. For this, we get x value, substitute the x value, find the y value. Now you know that the center is 3, 3. Use any of your points. You can use A, B, or C. All are there on the circumference, and find the distance of the radius. Perfect. So that is how you could do. Such questions could be extended to find area of the circle, right? So we could always, when you do your unit from here, once you can find area of the circle, correct? So pi r square, you know the area, radius, everything related questions. Does make sense?
Yeah.
Okay, so we'll end up with the example 15. And the most important thing which we have learned is point at a given distance. Now we're doing the reverse thing, right? So the question here is point A and B lie on the same line. So we are given 2 points on this particular line, which has a slope of 0.5. So we are also given the gradient of the line. A values are 3 minus 1. Find the coordinates of point B, which is 10 units away from A. So yeah, so this is a diagram of the previous one, however, but not relevant to this particular thing. So in this question, we are given point A, which is, I should say, do not go with this figure, right? It's the wrong figure. So we are given that point A and B lie on the same side, same line, and slope is half. So let's redo. Let's say this is my point. This is A given to us, and the coordinates of point A are 3 minus 1, and we know slope of this line M is half. Is that clear to you?
Yeah.
We want to find the point B, and the distance of point B is 10 units. Okay, so this is examination style question. Tell me, what are the coordinates of point B now? And how will you find coordinates of point B?
Can we start by finding the equation of the line?
Yes,
So y equals half x plus c.
correct.
Then just sub in because a lies on the line, just
Yes.
sub in that value.
Yes.
And have you worked it out? I can just
Yes.
take it from.
No, no, I'm sorry. This is not the right thing.
Oh, okay. Okay, I'll do it then. So, okay, I can't do it in my head. Wait 2 seconds.
No, this is not the right thing. So there's something wrong in this. So we'll not go with this. Sorry. Okay. So let's say.
I get the method. Okay, wait. So y equals half x plus c, and then we sub in 3 minus 1, so xy. So that's minus 1 equals plus c. Wait, 3 times 2 minus. Okay, so I got c as minus 5 over 2. So the equation of the line is y equals half x minus 5 over 2.
Okay. So first you find the equation of the line. Once you get the equation of line, how do you get point B?
Okay. So it's 10 units away.
Yes.
You don't use Pythagoras theorem, do you?
You could use a square. You could use the distance formula. So you know this 10 squared is equal to x. You don't know what this x is minus a x value, right? Plus y minus, which is plus 1 whole square, correct? So use distance formula. Now you got two equations. One equation which you just calculated, which was this equation of the line, y equals to half x minus 5 by 2, right?
Yeah.
Substitute that here for y.
Oh.
So
I didn't get that. Oh, so you put the equation into the distance formula.
now distance formula, you put the equation in, and you have got only one variable x. Calculate the value of x. Once you find x, you can find y. You get the idea? So it's not a straightforward question. It's like kind of very complicated. And therefore, I call this an examination style question, right? So this is definitely, this is the solution for the previous question. So you need to find the solution.
But then the distance formula is y2 minus y1 whole squared, right?
No.
But then
distance d square is x1 minus x2 whole square plus y2 minus y1 whole square. So I wrote 10 square. We just got rid of the square root thing, right?
Yeah, I meant the whole thing. I just short formed it to that section because when you, so if you, let's say you're left with y2, and then because you subbed in y1 as the minus 1, it becomes plus 1. How do you know that y2 is the same as just y on its own?
No, we know x1 y1 as 3 and minus 1 because point A is given to us.
Yeah.
So in the formula we have 10 square is the distance, right? Equals to, we are using one of these points. So we say 3, let's say 3 minus x whole square plus minus 1. We can use like this, minus 1 minus y whole square. So only unknowns are x and y, which are the coordinates of point B.
Oh.
Now, you know the equation of the line because both the points are on this line, correct? So you know that half x minus 5 by 2, whichever you found, substitute this value here for y. So it's a quadratic equation which is kind of complicated to work with. And then find the coordinates of point B. Is that clear?
Yeah.
So that is how you could do it.
Why are they both different though?
Pardon?
So why have you got 3 minus x and then you got x minus 3?
Oh, I just interchange their position. But when you square them,
Oh, okay.
yeah, yeah, yeah.
Oh, yeah, because it was positive. All right.
One and the same thing. But I will prefer to write this form since, x comes first, it is better.
Okay, yeah.
And, that is better. So I hope you have understood how complicated it could be.
Yeah.
Right? So today we actually learn a lot of stuff about coordinate geometry. Can you please summarize this for us?
Yeah.
Yes. Okay, well, good. You want to see the screen?
Yes, please. Because I can't remember all of that.
Yes, sure.
Right, so we started off quite easy, just the coordinate plane, so just knowing like the basics, knowing that if you have your x-axis, your y-axis, draw on a piece of paper, it would immediately be divided into 4 quadrants, and just knowing it goes 1, 2, 3, 4, like anti-clockwise, is just good and handy to know.
Yes.
And then we moved on to distance between 2 points.
Correct.
Which so that's, it looks complicated, the distance formula, but it's just simple Pythagoras' theorem, and simply doing that change in y over change in, like the y2 minus y1 over x2, and then so next we're on to, what's the title of it? Yes, that's distance between two. Oh yeah, so midpoint. So midpoint of a segment, all you do is you take your x coordinates, divide by 2, comma the y coordinates, divide by 2, and that would be your midpoint of the segment.
Yeah.
And
you need to know that.
And median, so knowing this terminology is quite crucial, because they would just ask find the equation of the median. So you need to know what the median is. It's the line from the vertex to the opposite side of the triangle, which is opposite side to the midpoint. So on an isosceles triangle, you said that's always going to be the altitude. However, on the scaling, it's just better to draw it. So don't assume that those 2 parts are equal, basically.
Perfect.
Then right bisector. So that's basically where it's so right bisector of a segment. So it's the line perpendicular to the segment through its midpoint.
Correct.
So when finding the right bisector, it's using all the other formulas we just learned into kind of one. So first you find the midpoint using obviously the midpoint formula. Then you find the slope, the gradient, doing change in y over change in x. Then finding the slope perpendicular to that would mean you need to just find the negative reciprocal. So make sure when you multiply them, you get -1. And then finding the equation of the right bisector, you use this formula because it immediately brings it into standard form.
Yes.
And it's much quicker as well, which is
point slope form of equation of line. Yes.
Oh, okay, yeah. So it has showed how it's derived. So it's y equals mx plus b. And we know what m is, which is y2 minus, or y minus y1 over x minus x1. And then when you cross multiply the 2 bottom, you get the point slope formula of
that is true.
a line. Yeah.
Last part was about the circle. So let's look into that circle 3 points. Yes. Can you tell me about this particular slide?
Yes. So, So when finding, so when we had the 3 points, the first step was to find the center of the circle. And then, so to find the center of the circle, what you do is you take the 2 points and you form a chord, and then we would find the midpoint. So you do the right bisector of that AB, and then you do the right bisector of BC, and then you make them equal to each other. Okay. And then you get your point, which is the center of the circle. Okay. And then you can just do the change in y over change in x, or like find the equation just by using one of the points. So it could be OA, OB, because anything to the circumference would be the radius from the center.
Perfect. That's excellent. So I guess you've understood everything and you're absolutely ready for the chapter on circle, which we are going to start in our next meeting. Okay?
Yeah, this was quite good because like having a foundation or a base before I get into it. Because yeah, it's quite good.
But I'll suggest you to begin with the exercise on circle, so that I'm sure you'll be able to do few of them based on what you have learned. Share with me the questions which you find difficult so that I could incorporate those questions while I teach you circles also, right?
Okay.
So that'll be a step ahead for you, but it'll be nice for us to, move forward. So share with me any questions which you have, and let's see how it goes.
All right. Thank you so much, sir.
Thanks.
I really appreciate it. Thank you.
All the
Bye.
best.